In this video lecture, we are going to discuss about solving taxonomy search problem. Let us look at the problem statement closely. In linguistics, hyponym and hypernym are the type of relationship taxonomy among the words or phrases based on their meaning. A word W2 is said to be hyponym of another word W1 if meaning of W2 is included within W1. Okay. So it is like a relationship between two words. It's like a hierarchical relationship. W1 is at the top and W2 is at the other end, right? So it is like W1 and then is related to W2. We call W2 as hyponym, okay? And when we will say this is if W2 is having the meaning which is included within W1. Okay, and we will call this as hypernym, which is at the top is called as hypernym and which is at the bottom is called as hyponym. This relationship is maintained. So for example, if you consider cabbage, spinach or hyponyms of green, peas, beans, okay, and hyponym which is hyponym of pulses. Okay, so if you take cabbage and spinach, it is hyponym of greens. Okay, so you have greens, right, and below greens you have cabbage and then you have spinach, and similarly when you look at peas and beans, they are hyponym of pulses. So you have pulses and this this peas and beans are going to be the hyponyms. Okay, this is hypernyms, this is hyponyms. And similarly you have got potatoes, yams as hyponyms of tubers. So you have got tubers as the hypernym and we have got potatoes and yams, because we know that potato is a tuber. Okay, basically it's a tuber. Similarly cabbage is a green and peas is a pulse, spinach is a green. Like this we have some kind of relationship between these words. So we call whichever is on the top as hypernym and whichever is the bottom is called as hyponym. And example is given. This is called as a taxonomy. When you have got this structure, we call it as a taxonomy. So the top of the taxonomy we have got vegetable. Under vegetable we have got greens, pulses, roots, tubers. All these things are basically vegetables. And when you look at this greens, we have got cabbage and spinach, and pulses we have got as peas and beans, and roots we have got carrots and turnips, and tubers we have got potatoes and yams. Okay, basically when you look at the lower level and try to relate to the topmost level also, all are vegetables, right? But the taxonomy can be formed like this between the names, right? So you see that in the above taxonomy we give some levels. This is at level 0, okay, which is a top level is level 0, and this is at level 1 and this is at level 2. We give these many levels, and in this problem we are going to consider only up to level 2. And another one example is also given. So when you consider color, purple, red, blue, green, all are colors, and you have subcategories for purple. You have crimson, violet, lavender and so on. So when you look at it, you say that at level 0 we have got color, and at level 1 we have got purple, red, blue, green, and at level 2 we have got crimson, violet and lavender. So now the problem is, when you are given n taxonomies, this is actually one taxonomy, this is one taxonomy, this is one taxonomy, right? But in the problem you are going to be given n taxonomies, right, and which will be having a maximum level of 2, and then you will be given a name P at level 0 and name L1 at level 1 and name C at level 2. Okay, check, you have to find out whether P, L1, C are at proper level of the same taxonomy, right? So the problem is, you will be given P, you will be given L1 and you will be given C, right? Now we have to find out whether there is a relationship like this. Okay, C is part of L1, L1 is part of P, whether this kind of relationship is present in any of the taxonomy. That is what we have to find out. Anyway, this is going to be level 0. So if you get an example like in this, let us consider this taxonomy. In this, if they ask us to check vegetable, greens and cabbage, then it is going to be yes, the taxonomy is present. But if they give vegetable, pulses and cabbage, then you will say no, because pulses and cabbage are not related. Okay, like that you have to analyze the structure and see. And look at the input format. In the input format, it is given that the number of taxonomies is the first input, because many taxonomies are going to be considered. And next few lines contains details of each taxonomy, and the order is also specified. First, you are going to have the name of the element in level 0 of the taxonomy. This will be repeated for each taxonomy. So if there are totally 3 taxonomies, then these things will be repeated for all these 3 things will be repeated for all the taxonomy. First input for that particular taxonomy is the level 0 name, and then next one contains some number of elements in level 1 of the taxonomy. It is separated by space. Our next few lines contains details of elements of level 2 taxonomy, and you will see that the first string here is the name of the element in level 1. Okay. Example is also given later, but let us finish the input format. That is how it is going to be. And next will be, after giving the elements of the n taxonomies, we are going to have a query, isn't it? So the query is going to have the name of the element at level 0, name of the element at level 1, and name of the element as level 2. So you are going to read all the 3 elements. You have to check, right? And what is going to be the output is, you are going to print like taxonomy present. Okay, if the elements P, L1 and C belong to the same taxonomy at appropriate levels, and taxonomy not present otherwise. This is the output format. And how we are going to solve this problem, what concept we are going to use. When you look at it, first of all, we have to represent the taxonomy. That is very, very important, right? And we are going to be given n number of taxonomies also. So what we are going to basically do is, we are going to consider first of all level 1 and level 2 of each taxonomy, and we will represent that using a dictionary. Okay, level 1 will be the key, and level 2 will be the list of elements in level 2 connected to the corresponding key, right? So you will have a dictionary representing the level 1 and level 2 elements of each taxonomy, and then we are going to have a collection of taxonomies. So again we are going to have a dictionary. So it's going to be basically dictionary of all dictionaries. Okay, and when you look at the key of the overall dictionary, it is going to be the level 0 element of each taxonomy, right? And value is going to be the dictionary formed with elements of level 2 and level 3, right? So let us take an example and try to understand. Yeah, let us take this example. So you are having what is said here is, you will represent greens, that is at level 1, and level 2 will be a dictionary, right? So let us have like let us call this as a taxonomy. Let me say like that. So you are going to form a dictionary, right? You will say that greens colon, right? And it's going to be list of elements. This is how it's going to be represented. And then we have to say pulses colon peas beans, and then we will have roots which has got carrot and then turnip. Okay, so level 2 and level 1 and level 2 elements are represented as a dictionary, in which key is going to be the level 1 elements, and value is going to be the list of elements corresponding to that particular key. So when I see, next is tubers. When you look at tubers, this is going to be the key and colon, and you are going to say the values there, potatoes and yams. Okay, so this is how the level 2 and level 3 of the taxonomy is going to be there. Let me call that as a taxonomy. And how I will represent as a whole is, I am going to have another one dictionary called as taxonomies. Okay, in which I will say this particular level 0 element will be the key. So I will say like vegetable colon taxonomy, right? So level 0 element is going to be the key in that particular overall dictionary, representing all the taxonomies, and the value will be the dictionary representing the level 1 and level 2 elements of that particular taxonomy. This is the idea behind representation of the data that is going to be given to us. Then after that, basically a more depth understanding of the dictionary operations would solve the problem. So let us start coding it. So the first thing is I have to have a taxonomies, which is an empty dictionary initially, and let us look at the input format. First thing is going to be the number of taxonomies. So let me say number of taxonomies, and I have to convert it into a integer. Yeah, and next few lines contains the details of each taxonomy, right? So for I in range, okay, for I in range 0 comma number of taxonomies you are going to traverse, and I am going to form a dictionary, okay, with level 1 and level 2 elements, right? And after that, after forming that dictionary, we will put it in the overall dictionary taxonomies, okay. So this is going to be the outer dictionary in which there are going to be n number of dictionaries, and these n number of dictionaries represent each of the taxonomy. So I am creating an empty dictionary to represent each of the taxonomy, and then you are reading the element of level 0, okay. Let me say level 0 is equal to input. And what is in the next line? Next line contains some elements of level 1 of the taxonomy separated by a space, right? So let me say level 1 equal to input, and it's going to be more than one element and separated by a space, so let me give it as split. And then next few lines contains the details of elements in level 2 of the taxonomy, right? And it is said that for each of level 1 there will be an entry, okay. So what is meant here is, basically we can say that in this level 1 you have got greens, pulses, roots, tubers. There are totally 4 elements. So in the input there will be 4 lines representing what are all the hyponyms for each of this particular level 1 element, right? So I have to know how many times I have to get it. For that, what we are going to do is, we are going to traverse the dictionary, right? We are going to traverse the lines. Input, how many times we have to get us? It is equal to the number of elements in the level 1, okay. Level 1 is actually a list. Since we have split it, it is going to be a list with elements at level 1. I am finding out how many elements are there, and I am going to read it now, okay. So level 2 will be equal to input dot split, okay. So once again it's going to be a list of elements, and when we look at it, when you look at the input format, or we can see that in that particular line you are going to contain the it's going to contain first value will be the name of the level 1 element followed by its children, okay. So you will be given like greens, space, cabbage, space, and then spinach. It's going to be like that, okay. Level 2 alone we are going to give the name also. So but now I want to form a dictionary. In this dictionary I want to have only the elements of level 2 as the values, okay. Key will be the element of the level 1, right. So let me say like taxonomy of level 1, okay. Taxonomy of level 1 is equal to level 2, and I do not want the first element, so let me say like 1 colon. So when I say 1 colon, the elements from index 1 will be entirely taken and will be put as here. But one thing that we have to consider is, that is given in the input format itself, if there is no children for that particular level 1 element, right, then it is going to be given as none. You can see here, if no element is present as level 2, for an element in level 1, then none is given. For example, when you look at here in this red, it has no children. Okay, so what will be given is none. The corresponding entry for red will be none, blue will be none, green will be none. Okay, so I am going to do this only if the value is not none. So let me look at here. How can I know this is? I can take the first value of what I have read for level 2. Okay, and I am checking if it is equal to none. It's a string. Okay, so I should check only like this. If it is none, then what I am going to do? I am going to just say, I am going to represent that by a empty list. It is left to you. Either you can represent that by a empty list, or you can ignore it by not putting in the list. It's up to you, but I am making it as generalized representation, where if there are no elements at level 2, then we are going to put it as a empty list, right? And if there are elements, we are going to take the elements alone and we are going to put it there. Okay, so here double equal to should be there, right? Okay, so let us check what happens now. We will just print the taxonomy. Okay, I want to print all the taxonomy, entire things, right? So after this for loop, okay, in this for loop we will be creating a dictionary for each of the taxonomy. But after that finishing of construction, what should we do is we should put it in the overall dictionary. Taxonomies of level 0 will be equal to taxonomy. Okay, so this will help us. Let us take the input. I have got the input here. So let me take this and check how the dictionary is formed. Yeah, so what is the error here? The point is you should not insert level 1 but the jth element at level 1. Okay, it should be the jth element. So when we write and see, we will understand. It's a list, basically it's a list of elements at level 1. Now we are processing the jth element of level 1. So you have to take the jth element and put it as the key inside the dictionary. So let us run it again. Yeah, you can see here. First we know that dictionary is unordered collection, so it will not come in the same order as we give it, right? This is the second taxonomy that we have with color. Okay, green is empty, blue is empty, red is empty, but you see that purple is with crimson, violet and lavender. And then you have seen sea animals, where sea animals are empty, and you see wild animals has lion and tiger, pet animals has dog and cat, right? And then we have got vegetables, where pulses are going to be, greens are going to be peas and okay, it's actually changed. I want to check whether I have changed the input or it is coming as a different thing. Yeah, let us see it. Yeah, okay, the input itself is given like that. The same hierarchy is not given, the hierarchy is just changed maybe to test, right? So the overall structuring is done. Okay, you have formed a dictionary of dictionaries to represent all the taxonomies that are going to be given in the problem. Next, what should we do? We have formed the dictionary. Next, you have to query the things, right? You have to get the details which are going to be queried, and then we have to start querying it. That's the left out thing. So first thing what we are going to read is what is the element that should be checked at P1, right? So let me call that as Q underscore L0, right? Q underscore L0 is going to be input, right? And next line is going to be the element that should be checked at level 1. So Q of L1 is equal to input, right? You read the next one, and next one will be the query what we have to make at L2, right? So that also you are reading it. I hope this is 0. Yeah. So 3 things we have read. Now we have to check whether these 3 elements are as a part of the taxonomy at appropriate positions, that is whether QL0 is at the 0th level, QL1 is at level 1 related to QL0, QL2 is level 2 related to QL1. This checking we have to do, right? For this we have to have little bit of understanding of now dictionaries, right? We have to make it out, right? And you will say either the taxonomy is present or not present. Now what are the different cases? QL0 itself might not be present, right? For example, here I have got 3 taxonomies with level 0 as vegetables, and I have got for level 0 as animals, and then I have got for level 0 as colors. If I am giving something else, trees, at level 0, then I will immediately conclude that this is not going to be the part of the taxonomies at all, right? So first thing we have to check is whether QL0 is present in the taxonomies or not, right? So we can say like, if not of, first of all, if it is not present, we will make decisions, right? If not of, right, taxonomies dot get of QL0. Be careful when you are going to use the things, because if you are going to use square bracket, taxonomies of QL0 you can use, but the difference is if you are using like that, if the element is not present, then you will get key error. So only Python has got one more way of accessing values of a given element, that is by that is get function. Okay, so here it is appropriate because there is a chance that QL0 is not part of the dictionary. Okay, so you have to use only get, and if it is not present, then what we are going to do is we are going to print, okay, taxonomy not present. Okay, and then if it is present, right, if it is present, then only we are going to proceed, right? And what we are going to do, if it is present, you have to check whether QL1 is present. Where will be QL1? It will be, now what will be your taxonomy of get.QL0 will give? It will give a dictionary, okay, because it is, the taxonomies is overall dictionaries of dictionary. So when I say taxonomies dot get of Q_L0, I will get another one, dictionary. Now in this dictionary I have to find out whether QL1 is present or not. If it is not present, right, if not of, right, not of taxonomies, okay, if not of taxonomies dot get of, it's always better to use get in places where we have the chance of not having the values, and then dot get of QL1, right. In this situation, what we are going to say? We are going to once again say taxonomy not present, right. This is what we are going to say. And the third case is if it is present, right, if it is going to be present, then what we are going to do? So these things should be executed only if it is if the condition is false. Okay, this condition will be false if this is present. So let us put it in LF, right. Now again let us put it in LF, right. If you do not have QL2, okay, now Q not is present, that is, for example, you have been given vegetables, it is present, and then next you have been given greens, that is also present, but next you have been given like coriander leaves, which is not present. Okay, so failure may occur at any level. We have considered QL0, we have considered QL1, now we have to consider QL2. Okay, so when you look at what you get, right, for example, taxonomies is a overall dictionary. When I am going to query for QL0, I will get the values corresponding to Q_L0, which is a dictionary again, right. So I am using again get function to find out whether the element at level 1 is present, right. For that only I have used get QL1. If it is present, then what will be the thing? Next, what you will get is a list, because when you look at level 1 and level 2, it forms a dictionary of each taxonomy. Level 1 will be the key and level 2 will be the list of corresponding values, right. So here I am going to get a thing. So let us do this LF I will take this, right, and I will check whether not of Q underscore L2 in, because it's a list, I can just check it whether it is present or not, right. If it is not present, then you will say that it is not present. If none of these conditions are met, then I can confidently say that the taxonomy is present. These are the three cases that I have to handle for not present. If none of them have been met, since I am putting else if, I can say in the else part that the taxonomy is present. Okay. So let me comment this one and try out. Yeah, taxonomy is present here, right, and I hope I can try it out here. Sorry. Yeah, so this code is working. So it is very important that understanding the problem is very important. When you look at this problem, the challenge was understanding what is said in the problem. It's a new concept for many of us, and also how to represent, how effectively we can use the representation so that we can query it easily. That was the challenge. Hope you have understood and you have enjoyed this particular problem. Thank you.